Good morning, grade 12s. Today we are going to be talking a bit more about log functions or logarithmic functions. Now, from yesterday's lesson, I hope that you remember that a log function is always the inverse of an exponential function. So I'm just going to write that next to the heading. All right, the inverse of an exponential function. Now, I'm just going to write as an example if we have an exponential function. So I'm just going to say exponential. That is usually written in this form. Now, I'm going to just make it kind of as simple as possible. This is similar to the one that we drew in class yesterday, y equals 2 to the x. Now we're just going to look at y equals a to the x. So instead of 2, I'm just using a variable a so that it's more general. Now when you take the inverse of that, remember that we learned that for the inverse, you always have to swap the positions of x and y. So if I'm going to do that, if I have y equals a to the power of x in my original function, I'm going to end up with x equals a to the power of y. So that is the first step of finding the equation of any inverse, is swapping x and y in the equation that's given, and then you have to make y the subject of the equation that you get once you've swapped your x and y around. So now I've swapped my x and y, and now that means that next up I need to make y the subject. Now guys, up until this point we actually haven't worked with equations like this where we have to make the exponent the subject, right? If we had something like x equals a times y, that would be very easy. How would we get y on its own? We would simply say x over a is equal to y. All right, I'm hoping that you guys can recognize that there is a difference between these two equations. We don't have x equals a times y. We have a to the power of y. Now what we use in order to now make the exponent the subject, which like I said is something that we haven't done before, is we use log form, logarithms, logarithmic form. So now to make the exponent the subject, use log form. Okay, now how log form works, I'm just going to write this x equals a to the y again. X equals a to the y. So we want to make the exponent the subject. So we are going to rewrite that by doing just that, by making the exponent the subject. So I'm going to say y equals. So whatever your exponent was, it will always be y when we're working with these equations. So you start with your exponent being the subject. Then you're going to write log, and like I said yesterday, you are allowed to use a cursive L like I do, or you can just use a normal L, it doesn't matter. And now, hopefully from yesterday's example, you should remember that the base of the exponent is going to become the base of the log. And we write it as a subscript, just next to the word log. All right, and then what was left in this equation now that we have not yet put in our log form of the equation, the x. So the x then is written behind or just after the log base a. All right, so I'm going to write a few steps down here. The first thing that you're going to do is exponent becomes subject. Right, so the exponent of x equals a to the y was the exponent, so y became the subject. The next step is base of exponent becomes base of log. Right, so the base of our exponent that we had was a, so the base of the log also becomes a. And then the last step is just to write x next to log base a. So yesterday we had the example y equals 2 to the power of x, right? That was the original function. Then I just made you guys write next to it that the inverse was y equals log base 2 of x. But where did that actually come from, guys? I left out that first step where when you're finding the equation of an inverse, you always swap x and y around. So it would actually have been first that x is 2 to the power of y, and you then write it in that form. Now, in a test or exam, you don't actually have to show this step. You don't have to show how you are swapping the x and y around. You can go straight to log base 2 of x. So if you guys want, you can remember, okay, we have an exponential graph. We have y equals 2 to the x. What is the inverse of an exponential graph always? A log graph. So if it's 2 to the power of x, the equation of the inverse is going to be log base 2 of x. If you have y equals 3 to the power of x, then the inverse is going to be y equals log base 3 of x. But again, that is actually coming from, if we take this equation and we swap the x and y around, we're going to have x equals 3 to the power of y. Now the exponent becomes the subject, the base of the exponent becomes the base of the log, and then we write the x down last. So like I said, you're more than welcome to write the step x equals 3 to the y, but you can also leave it out if you just remember that. The same thing happens when we have fractions in our equations. We know that it's quite, or it happens quite often that you have like y equals a half to the power of x. In this case, the inverse is going to be y equals log base a half of x. So same exact thing, your half, your base of your exponent is going to be the base of the log. Again, it comes from this. If we were to, if we were to swap the x and y around in our equation, we would get this. X equals a half to the y, in which case the exponent becomes the subject, the base of the exponent becomes the base of the log, and we write the x last. Okay, now grade 12s, this is going to become quite useful for us because we are now going to be able to solve equations, exponential equations that we might not have been able to solve previously or to solve before. If we have something like, say the instruction says, solve for x. Now I'm first going to do an example that we don't need to use logs for so that you can see what I'm comparing it to. If we had 3 to the power of x is equal to 27, right? We have an exponential equation. Now we've just done a couple of exponential equations when we did the sequences in series topic, so you might be familiar with these. Now remember, when we have an exponent, or the variable rather, in the exponent, so I'm just going to write there, variable in exponent. That means that we have to make the bases the same. So I have a 3 to the power of x equal to 27. The 27 I also need to write as 3 to the power of something. Now 27 is 3 to the power of 3. Now that means if we have 3 to the power of x equal to 3 to the power of 3, that x would have to be 3. But now what's going to happen if we are given an example where we can't do that? So like 3 to the x is equal to 28, for example. Again, we have the variable in the exponent, so we would want to or need to write both bases or both numbers with the same base. So we have 3 to the x equal to 28. Can we write 28 as 3 to the power of something? We can't, right? I mean, we could be able to, but it would have to be a decimal. And who's going to check for that? Who's going to actually test to see which exact decimal number is going to give you 28? So 3 to the power of what is equal to 28, right? We don't know. We're not going to test decimals. In grade 10, you actually did do questions like this using a method called trial and error, which was a very, very long method. All right, so in this case, guys, we cannot make the bases the same. We cannot make bases the same. So we are now going to use logs. We are going to use this rule that we wrote up here, and we are going to rewrite our exponential equation as a log equation, which is going to allow us to solve for that exponent. Guys, what did I write in this rule? We use log form when we want to make the exponent, which was y in this case, the subject of the new equation. We have exactly that in this example that we're looking at now. Sorry, I'm just trying to get back all those dots. We have that in this example, guys. I want to solve for x. So I want to make x the exponent. I want to make the subject. I want to have x equal to something that I can then calculate. So I want to make my exponent the subject. So I'm going to use log form. So therefore, convert the exponential equation to a log equation. All right, and then we're going to be able to solve this equation simply by using our calculator. So remember, what was the rule? The exponent becomes the subject. We've already done that. The exponent was x. Now the subject of my equation is x. Then we're going to write log. The base of the exponent is going to become the base of the subject. So we had 3 to the power of x, so we're now going to have log base 3. And then all that's left is this final number 28, so we put that behind the log. Now you're going to take your calculators, guys. It is the button underneath the on button. Looks like this. So calculator, unfortunately I can't show it to you now because I'm just screen recording. But the button literally says log, and then it has a little block there and then a block next to it. So you are going to press that button. Then you are going to type in each block. You're going to type the number. So you're going to press that button. Then you're going to press 3, I think would come next. And you're going to use your arrow and you're going to press or type in 28. And you're going to press the equals button. Okay, I'm actually not sure where my calculator is here. All right, so I'm pressing the button. The cursor is already in the first block, so that's why I'm going to type my 3. I'm going to use my arrow to go to the next block. I'm going to type 28, then I'm going to type or press the equals button, and my answer is going to be 3,03. And that is 0.333103, so it has lots of decimals. We can just round to 2 decimals. All right, so 3,03 is the answer to that equation. Okay, there are a few things that you need to just know about log equations, like when there are minuses, what you would do with those minuses, because there are different things that we need to think about. So let me just quickly zoom out, see how we're doing for space. All right, I'm going to just make a little heading here. please note okay, these are just a few things that you need to remember about logs and log equations. We've never worked with equations like these ones before, and they have certain restrictions to them. So if you have, I'm just again going to write the basic rule. If you have a equals, and let's use different variables this time so that we can get used to converting to log form. So if you have a equals b to the power of x, and you want to convert that, and now guys, I'm actually going to use like a double-headed arrow, because you can convert from exponential form to log form, but you can also be expected to convert from log form to exponential form. So you do need to be able to apply this rule both ways. So what you're going to do is exponent becomes the subject, equals, then you put your log. Base of the exponent, which is b now in this case, is going to become the base of the log, right? And then the last number or variable or letter, whatever it is, that's left goes after the log. Okay, so there we have our a. And let's just put an arrow. Exponent becomes subject. All right. Now, guys, if you have something like this, a equals b to the power of negative x. Now my x is negative, obviously, right? So now when I convert this, what is the exponent now? Not simply x like in the previous one, but negative x. All right, so that negative needs to just go with the x. Obviously, it's negative x, so the whole thing becomes the subject. Then the rest of your log is going to be the same. The base of the exponent was b again, so that becomes the base of the log, and then I was still left with a. Now guys, what you are normally going to have to do with this is you are going to have to move that negative over to the other side. So you're going to have x equals negative log base b of a. Now where this comes in handy is if you have something like this. If you have y equals a half to the power of x, which we did look at previously, we said that this is the same as, or the inverse rather, sorry. The inverse, you would write that as x equals a half to the power of y, right? And then you would say, okay, exponent becomes subject, base of the exponent becomes the base of the log, and then you put your x. But y equals a half to the power of x can be written in a different way. It can be written as y equals 2 to the power of negative x, right? These two equations mean the same thing. 2 to the negative x and a half to the x, those are equal. So now if we're looking at this, we would say that the inverse is going to be x. Sorry, let me just write inverse again. The inverse is going to be x equals 2 to the power of negative y, in which case we're going to put our exponent now is going to become the subject. We're going to say log base is 2 of x. And now, of course, we can't leave the equation like this. We would have to move that minus over to the other side. So this would be the final answer for that equation. Now, guys, these two equations are actually equal to each other. All right, they come from the same original function. Y equals a half to the power of x is the same as y equals 2 to the power of negative x. So their inverses would also have to be equal. All right, so that is something that you can also remember. So we can write this as a rule that if you have, therefore, if you have y equals log base 1 over a of x, right, if we have a fraction, then that is the same as, say, is equal to y equals, now if you don't have that fraction as your base, you have to have a minus in front of the log, and then it's going to just be the whole number. So basically the denominator. So I'm looking at 1 over 2x compared to 2x, right? I'm looking at my first highlighted log equation compared to my second highlighted log equation, and I'm looking at the differences between them. So either I have a fraction as the base of my log, in which case the whole log is positive, but if I want to have just the denominator of that fraction, so a whole number, then I have to have a minus in front of that log. All right, you can swap between these two without showing any working. I just wanted you to see that they are actually the same. They actually come out to the same thing. All right, now the last thing, I'm just going to have to go to, let me actually move this across, then I have some space next to it. Right, you might have to write on the next page. All right, the last thing that we are going to write down about logs for today is that if you have something like this, a is equal to negative b to the power of x, we do sometimes get exponential equations like this. For example, y is negative 2 to the power of x, right? So where you have a minus 1 there in front. Now guys, in this case, and we are going to again use our double-headed arrow to show that we can convert between them. What you are going to have to do actually is you're going to have to just underneath show that you are moving the minus to the a's side. All right, it's very important that we don't actually keep that minus with our b, with that number that's there. I'll explain to you now why that is. All right, so we don't want to put the minus in front of the base of the exponent. We want to put the minus in front of the base of the, or in front of the a, whatever is on the other side. All right, so let's rather do it like that. So therefore, okay, so the minus we move, that is important. Let's use a little arrow there. Then we are going to say, okay, exponent becomes a subject equal to log base, the base of the exponent becomes the base of the log, and then we're going to have a negative a in those brackets. Now guys, the reason for why we couldn't leave the minus in front of the b's, please I excuse the dogs barking outside. The reason why we couldn't leave that minus there is if you can just quickly take your calculator, right, and just press the log button for me. Just put any negative number in that first block. So let's say negative 2, for example, and then put a 5. All right, so if you type into the calculator log and you put a negative 2 and you put a 5 and you then press equals, that will come back as a math error. The base of your log can never be negative. So therefore base of log cannot be negative. So if you have an equation that's written in exponential form and you see that the base of the exponent is negative, so therefore if base of exponent is negative, then move minus, I'm just going to put a little circle around it, to the other side before converting to log form. Okay, now I know that this seems very confusing. I don't feel bad if it does. It's a completely new thing to work with, completely new kind of way of writing things, completely new notation that you haven't worked with before. So give yourself some time just to get used to this whole concept of logs. I don't want you guys to stress about it. There are a few more general laws that we will look at in class tomorrow, but for now, I just want you guys to practice some of the log equations and kind of converting from exponential form to log form and so on. There's one more thing that I want to put here, guys. Please just write next to this that if you have a negative a in your brackets, that a must actually also be negative. Now, why I'm saying that is also this number, also actually, like when it's an actual number, also can't be negative. That will also not give you an answer. I almost don't want to say it because I don't want to overwhelm you guys, but I feel like I can't just leave this notation kind of written not fully. So if you have a negative a, right, but now I'm telling you that a is 1, then that means that you have negative 1 in that bracket. So if you just type log and let's put a 2 in there and a negative 1 in the bracket, it will also come back as a math error. But now, if you have log with a negative a, and I'm telling you that a is a negative 1, right? What will you then have in the brackets? Then you're going to have negative a, which is negative 1. So you're going to have positive 1 in your brackets. Okay, so that will actually give you an answer of, I think it's going to be 0. If we do log base 2 of just 1, yes, your answer is 0. Okay, so if you have a negative variable in as the number after your log, then you just have to state this as an extra, please. We can chat about it a bit more tomorrow. We'll talk more about log form and log notations tomorrow. But you would just have to state that if you have a negative variable in the bracket, the actual value of that variable, if we assign a number to it, would have to be negative. Because if you have a negative, it will give you a positive. Okay, I quickly want to go across to the TUT to see what you guys can do now. So if we look at grade 12, sorry, that's actually the wrong page. I want to go to the main one, grade 12 maths. If we go to classwork, and then we are on functions and inverses, and we go to tutorial 3. All right, so you can now do some of these questions in number 5. I don't know if you guys have worked through 1, 2, 3, 4, but you need to do some of the questions in number 5. And then also number 6, they're saying that number 6 are equations. The questions in number 6 are equations questions, so you can do those. And then, yeah, 7 and 8 and 9, we can talk about those tomorrow. All right, grade 12s, have a lovely rest of your day, and I will see you guys in class tomorrow.